Hey, this video here is just some basic skills of how to solve a one-step equation in Algebra 1.
Welcome. We're going to learn how to solve for x. So there's basically three different scenarios that take place in order for us to solve. So you might have to undo this by subtraction. You might have to undo this one by addition. You might have to undo this one by division. And you might have to undo this one by multiplication. So let's do the first one. So these are being added together. So to undo addition, we do subtraction, and that would yield us to the answer 8 minus 3 is just 5. This next one, this is a subtraction problem, so the opposite of that would be addition. So we would come up with an answer of x equals 14. This is multiplication. So to undo multiplication, we're going to do division, and yields us with an answer of x is equal to 7. And the last one, this is division, so the opposite of division is multiplication.
This is the most basic
And
of
that
math
gives us
that leads
x
to
equals
how
28.
we launch rockets
all I
into
got.
outer space. Video here is just some basic skills of how to solve a one-step equation in Algebra 1. This last video would be something that you would be leading to eventually in Algebra 1 when you make the transition after geometry to Algebra 2.
Good morning. How are you doing? Good. We actually are going to get that back in class today. We went through it all, and together as a class we walked through it, and then I'm handing it back today. We also went through tons of practice test questions. Do you have questions? Do you have time? Do you have questions right now, or do you? Yeah. Do you want to go through some of those? Okay. And I'm trying to think. I've got one person that hasn't taken the quiz, so that's why I can hand it to you in class. Is that cool? Yeah. Okay. Just yesterday you said we were going to do something in class, or you guys just go over it? Well, okay. So yeah, you're right. We were going to do the last quiz together, and we had so many good questions on the practice test that we didn't get to that, so I'm saving that for today. So if you've got some practice test questions, I can answer that for you right now. And then so we just went through a lot. We went through the first quiz, and then the other thing that we'll do in class will be today. But you have some practice test ones? Okay. So once you are free to get set up, and then I'm just looking through a problem for another teacher, and then but certainly as soon as you're ready, I can answer questions. Tonight your turn. fit that are super critical to our understanding. And you want me to go through those with you, at least to start. Now, I love what you did on 10. That's exactly what we want you to do. In the circle, and I'll come back to this, but already I and then we drop to an auxiliary radius there. And I like the fact that, sometimes students go, well, we must bisect the angle. Not necessarily. We have to use the angles or sides of the angle. So those are congruent. That's 40, that's 40. You got 40 in there. On the quadrilaterals, let me show you the proper way. You got the right answer. So let's make sure that that wasn't a special case. But since we started talking about that, let's do that. We see a circle. I'm thinking already got it. We'll do the circle A. And you decide for X. And this is one of the rare situations so far this year where we're asking for a reflex angle. Well, we're given 40 degrees, 80 degrees. Sometimes people go, oh, I'm going to draw a segment. I don't see any triangles. I'm going to draw a segment from here to here to make 2 triangles. I understand why they do that. But without the circle, we wouldn't be able to solve this problem. With the circle, already I have congruent. Now, here's how we handle this. We draw an auxiliary segment, which happens to be a radius. We don't want to assume that we bisect that angle. It could happen in a couple of cases, but not here. Adding in an auxiliary segment, we have 2 triangles. So watch how we handle this. We cover this one up. We have hands, right? The larger the angle, the longer the side cuts, right? Well, like this, we also know their sides and their angles. So if that's it, if those 2 sides are congruent, if that's 80, that's it. And because the sum of the angles of the triangle equal 180, the difference between 160 and 180 is 20. Now do this. Cover that up. You can notice there are 2 tick marks and 2 tick marks. Some students yesterday were thinking, oh, 2 tick marks here, 2 tick marks in here. So these angles must be the same. It depends on that first example. So if sides, then angles. Well, if that's 40, it would make sense that that's 40. Together that's 80. It doesn't look like it in sketch or up here. It wouldn't just be 100 degree angle. Now, X is made up of 80 plus 40. So that's your 120. That's your 120. Just coincidentally in this problem that ends up being 120 as well, then the reflex is 240. So you got the right answer. You obviously have some experience with some of this, but that angle should be 40 and 80 based upon size. Does that make sense? I'll give you this. Okay. Number 2. I consider it to be a fundamental problem to check. And may or may not be an issue for you, but I've found that some students in a course in different sections struggle with the economic expressions and are solving something in terms of a particular variable. We have y, and we have a, c, d, and b. I have x. We want to solve for y intermediate. So we're going to get y is is equal to an expression. This is super important and relates somewhat to this without a circle. The given information we have is that size congruent to this. Now, before I put the last given in, that's why if sides and angles, we don't have anything really to go on just yet. But it goes on to say, no, it's not drawn to scale here or here, and that CD is congruent to each of those. So here's how we start. Cover that up with sides and angles. So that's X. Now, if that's X and that's X, we write an expression as a scale. 1, 2, degrees. And then cover that. Demonstrating what we learned in chapter 1. Are these supplements that we learned in chapter 2? If that's 180 minus 2x, we got 2x. And then size of angle, that's 2x, because of this x. Now we know that y plus 2x plus 2x is equal to 180 because it delta x up to 180. We're going to solve for x. So that y is equal to 1 to b minus 4x. Which will cut it down like that.
Well, like I do this one thing except I didn't like how if these are all convenient. So they're able to like if this was X but then use two sides of the same and even
Great question. It all depends on the vertex up. Now, there's another way to look at that. I understand that if you see X and X and see two here, you might think that's X. But let's do this. Good question. What if I'm sticking out numbers like this? And now I'm going to throw some numbers in. I'm going to call this 40 degrees.
All right, guys. Finally, I'll be talking, so hopefully you got through your homework just fine. Hopefully everything's going well. We're going to start factoring. I'm going to show you a way of factoring by grouping, but a lot of times we want to try and get it quicker. So let's go to the first thing. Main thing is let's factor out any common factors that we might have with our problem. Okay, so on this first one, we do have a greatest common factor. It looks like I could factor a 3 out of both, and I can factor x squared out of both. So I get 2x plus 1, and this is factored completely now. So that's when you do it. Taking a look at number 2, we can factor a 5 out of both. I can also factor an a out of both, so I'm left with a minus 2. That's my complete answer. It's not equal to 0, so we're not solving it at this point. Down here on number 3, it looks like I can factor out a 4 and an A and a B. I can't factor out any more from anything else. If I factor a 4 out of 12, I'm left with 3. The A's canceled out. If I factor B out of B squared, I'm left with a B inside. The minus sign comes along. Factor a 4 out of 16, I get to 4. Factor an A out of A squared, I'm left with A. The B already got factored out. And then plus, factor a 4 out of 8, I get to 2. There's no AB. And so that is our complete answer. There's nothing more to do with that. Sometimes you have a common factor as two binomials. So take a look at both of those. They're the same between both pairs of problems I have there. So I can factor out an x plus 3 from both of them. So now we're going to ignore it, and then I'm going to write whatever I have left, keeping the sign, so that becomes my other binomial. And this fits into our factor by grouping that we'll eventually start getting to. I think we're missing a parenthesis on this one. So go ahead and factor an x minus 1 out of both. and then you have 5x minus 10. If you get to this point, you'd have 1 point off. The reason you have 1 point off is I have a greatest common factor there. So I can factor a 5 out of both of those. X minus 1 stays the same. If I factor a 5 out of 5x, I'm left with x. If I factor a 5 out of 10, I'm left with minus 2. So this is my entire answer. Problem number 6, I do have these common values. So I have x minus 5 that I can factor out. So those cancel each other out. And I'm left with x squared minus 9. If you left that like this, you'd miss a point because you didn't recognize this is difference of two squares. Difference of two squares, remember they're conjugates of each other. So you get x plus 3 and x minus 3. And now we have this one. This one looks a little different. So this is what I want you to do on this one. I want you to replace this and this. We're just going to replace with y. So I have y squared minus 5y minus 24. We're going to go ahead and factor that. So I'm going to get y minus 8 and y plus 3. But you remember what y was equal to in the beginning? It was equal to that. So now I can replace that on both of those. So there's a little deeper thinking on this problem. So I'm going to plug in for here. I'm going to get x minus 1 minus 8. And on this one, I'm going to plug in x minus 1 plus 3. Combine any like terms. So x minus 9 there and x plus 2 there. A little more tougher, but you have to realize you can substitute a different variable in, do the math, and as you're doing the math, make sure you plug it back in to those y's. So a lot of times when you're reasoning with factoring, it's best if your lead number in front of the x squared is a prime number. That makes it easier because there's only one way to get a prime number by multiplying it together, two numbers together. Factor by grouping, determine the product to take place. So let's take a look. So the nice thing is this is prime. So I'm going to do this one a little bit the faster method. The way I would get 3x squared is multiplying 3x times x. Okay? And then from there we have to kind of think, I have this 5. So how would I get to a 5 where once I add my terms together it would add up to negative 8? Well, this is a positive sign, so I think both signs have to be negative. And I'm going to do a 5x right here, or 5 here, and a 1 here, because if I go 3x times x is 3x squared minus 5x minus 3x gives me that, and then there's our answer. So that's the quicker way of doing those, especially when it's prime. Letter B, I know I'm going to have 7x as my first term and x as my second term, because if I multiply 7x and x together I get 7x squared. And then I have to figure out where I'm going to get this 3. Where would I plug this 3 in? Well, I'm looking at my signs. They're both positive. So do I put the 3 here or do I put the 3 here? Well, you have to play with it a little bit. I think you have to put the 3 on the outside and a 1 on the inside. And let's double check. That gives me 1x and 21x. So that's my entire answer. And it starts getting a little tougher. When my lead coefficient is not a prime number. Take a look first. Does 6 go into 19 and 15? It doesn't. There's no factors other than one that work. So what I'm going to do is we're going to multiply those two numbers together. So I get 15 times 6, and 15 times 6 gives me 90. And then let's think about the factors of 90. So I get 1 and 90, 2 and 45, 3 and 30, 4 and I just spaced that. Nope, 4 won't work. 5 would work. So I get 5 and 18. 6 should work. So I get 6 and 15. 7 doesn't work. 8 doesn't work. 9 and 10 both work. Okay, being that 9 and 10 work, and this is kind of the 90-10 plan that I was telling you about the other day. These will be the factors. When I add them up, that will give me 19. You know that they both have to be negatives because I get to a negative 19, and this is a positive. So then when we do this by grouping, what we're going to do is we're going to go 6x squared minus 9x minus 10x. You could have flip-flopped them and it's still going to work, plus 15. And then we're going to look at my first two terms. It looks like I can factor a 3 and an x out of both of those. That gives me 2x minus 3. And then on this one, be aware of this sign, so it has to be a negative. And then it looks like between these two, I can factor out a 5, and that leaves me 2x minus 3. And then notice this, the 2x minus 3's are the same. So my answer is 2x minus 3 and 3x minus 5. That's kind of doing it as grouping. Okay, sometimes grouping is a better method to use. So let's try this next one. 4 hasn't have any factors the same as 19. It has the same factors as 12, but the 19 doesn't work. So what I'm going to do is I'm going to take these numbers, I'm going to multiply them together, and I get 48. Think about the 48, the factors of 48. 3 and 16. I think those would work. Yes, so there's more factors, but I think 3 and 16 will work nicely. They both have to be positive because all my signs are positive. So I'm going to get 4x squared plus 3x plus 16x plus 12. And then we're going to look at the first two terms and factor out what we have in common. Looks like I can factor an x out. And then I'm going to look at my last two terms. Remember, that sign's positive, so this one has to be positive. And it looks like I can factor a 4 out. And then I have the 4x plus 3's that are the same, so the grouping method worked. And whatever I have left, I write as its own binomial. Same thing, check to see, does 3 go into 17? It doesn't, so we can't factor anything out. So I'm going to multiply 24 and 3 together, and that's going to give me 3 times 24 is 72. Think of the factors of 72, that would add up to 17, or negative 17 in this case. 2 and 36, 3 and 24, 4 and, let's see, 4 and 18, 5, 6, and 12, 7, 8, and 9. 8 and 9 both seem to work. Notice though, there's the very last two factors, the ones closest together, that work. So that's kind of a key on some of these. Again, it's that 90-10, but we'll talk about that a little bit more next week. Both values have to be negative because when I multiply them together, I get a positive. And realize it's not multiplying to get to the 24, we're actually multiplying to get to the 72 with these factors. But then I have the minus 8x minus 9x plus 24. I can factor an x out of both of those. Remember that sign's negative, so it has to be negative here. And I can factor a 3 out of both of those. And if I factor a negative out of the positive, that has to become flipped. And then those are the same. So I get 3x minus 8 and x minus 3. Letter F, same thing. Does 8 have anything in common with 26 and 15? It doesn't. So I'm going to multiply 8 and 15 together. I get 120. Factors of 120 are 1 and 120, 2 and 60. And I'm trying to get the ones that add up to 26. 3 and 40, getting closer. 4 and 30. 4 and 30 looks like it might work. But everything's positive, so I don't think that's going to work quite well. Let's try 5. So I get 5 and 24. Let's try 6. So I get 6 and 20. There we go. If I add 6 and 20 together, I do indeed get that 26. So I'm going to write my first term down. So I get 8x squared. And they'll both be positive here because everything's positive here and here. So plus 6x plus 20x plus 15. Take a look at your first two terms, and again, if you had 20x right here, you'd be fine, it'd still work. If you had 6x here, it would still work. But you have to pick one particular order and stick with it. So let's see, we can factor a 2x out of both of those. And when I look at these, remember that term's positive, that's fine. I could factor a 5 out of both of those. So then I have a 4x plus 3 and 4x plus 3 on both of those. That leaves me 2x plus 5. And that answer is done. Let's see how many more we got. A couple more? 2 more. All right. All right, factor out any common factors. Okay, so then now we're going to have a greatest common factor. So it looks like a 3 goes into all 3 of those. So I'll bring a 3 out front. All 3 terms have an x, so I'm going to pull an x out. If I factor 3x out of 3x to the third, I'm left with x squared. Factor 3x out of this, it's going to be minus 2x. If If I factor 3x out of this, I have to have a placeholder of 1. And this does indeed look like it will factor. It's going to be x minus 1 and x minus 1 if you do it quickly. And the reason they're both negative is negative 1 times negative 1 gives me positive 1. Negative 1 plus negative 1 gives me negative 2. So this is our answer. On this next one, we're going to take a look. Looks like I can factor only a 5 out. So then I'm going to get 5x here, squared still, minus 3x, minus 2. So now we have to remember this is going to be part of the answer. I'm going to put it way down here. Okay, let's take a look. Can we do it our quick way? Well, this is prime, which is nice, so I'm going to have a 5x and an x. And how would I get to that 2? So I can put the 2 here or here. We have to make sure which one works. Looks like I'm going to have alternating signs, and we need to somehow add up to 3x. So I think if we put a positive 2 here and a negative 1 here, let's see if that works. That's positive 2x, that's negative 5x, that gives me a negative 3x. So that's the rest of my answer. Okay, again, you could have done this the other way where you could have multiplied by negative 10, where you're multiplying that and that. We're ignoring this for the problem, and then you have to go through and say, oh, which factors of 10 would work that would add up to negative 5, or add up to negative 3, and that again would be the 2 and the 5. You'd have to realize the 5 would have to be negative and positive there. And if you plug that in, it's going to go ahead and work out the same way. Okay, letter I. 2 terms. Immediately should think difference of 2 squares, but those aren't squares right now, so I'm going to factor a 3 out of both. This is now difference of 2 squares. That's going to give me 3x plus 1 and 3x minus 1. On letter J, the important thing is realize I can factor a negative 5 out first. That leaves me this. I got to change that sign now to a negative. I got to change that sign now to a negative. And then the two numbers that multiply together to give me 10 are negative 10. So I got 1 and 10, one of them negative, one positive, 2 and 5. Is there any way that I can make one of these positive and one of these negative to add up to the negative 7, or it won't? So this is actually the completely factored form, because this part would have been prime, but don't list it as prime and show that it is factored out. On number 5, solve each equation by factoring. Okay, so we want to solve each. So it looks like I can factor 2 out of everything. Plus 9 equals 0. Let's factor this. This 2 is actually not going to do anything. What I could technically do is I could divide everything by 2. And that would just leave me x squared minus 6x plus 9 equals 0. And then you might see that this is x minus 3, and x minus 3 equals 0. So my answer is just going to be a positive 3. If you list them both, that's fine. This is called a double root a lot of times because it would have been the same exact answer. That would actually bounce off the x-axis if we had graphed it. This one appears to be the difference of 2 squares because 25 is a perfect square, x squared is a perfect square, and 49 is a perfect square separated by subtraction. So I'm going to get 5x plus 7 and 5x minus 7. And we're going to need to set each of those equal to 0, so I get 5x plus 7 equals 0. So 5x equals negative 7. So x equals negative 7 over 5. And then on this one, 5x minus 7 equals 0. 5x equals 7. So then x equals 7/5. So I have a positive and negative component for both of those. Those are the solutions or the roots, like that. On problem number 7, let's take a look. We don't have a greatest common factor because 6 doesn't have any of the same factors as 11. So we're going to do this. We might have to do this our grouping way. So I'm going to multiply those together so I get negative 60. And let's think about the factors of negative 60. So 1 and 60, one of them is negative, 1 is positive, 2 and 30, 3 and 20, 4 and 15. That's going to work. That's going to work. And in order for that to work, in order to get a negative 11, that has to be a negative. That has to be a positive. So we're going to go 6x squared. Doesn't matter which order we put these in, just make sure the signs come along with it. These are still equal to 0, but now we're going to go ahead and factor. So look at the first two terms. I can factor a 3 and an x out, so I get 2x minus 5. Plus sign comes along for the ride. I can factor out a 2 out of both of those. That gives me 2x minus 5. Remember, these are equal to 0. So then I get 2x minus 5. And then, because I had those both the same here and here, so let's not worry about those. And then I have 3x plus 2 still left. Set those equal to 0. So that gives me add 5 divided by 2. And then the second one, set that equal to 0. Subtract 2 divided by 3. There's my two answers there. Problem number 8, kind of a little challenging because there's an extra x. You have extra to the third, so let's move the 40x over. Minus 40x. Take a look. Yes, I can factor a number out of everything. Looks like 2 goes out of everything. I can also factor an x out. That's going to leave me 3x squared plus 7x minus 20, set it equal to 0. So let's remember this one, 2x equals 0, so x equals 0. There's one of my solutions. And we're going to take a look. We might be able to do this our quicker method. So I have 3x because that's prime and x. And then we need to somehow get to the factors of 20 that would add to 7. Let's see. 4 and 5 might work. We're going to go our grouping method. So we're going to go to negative 60. So we have the factors of 60 still over here, so let's take a look at those. Which ones would add up to 7 if we had done it? I think I needed to still have 5 and 12 in there, and the 5 and 12 would work in this case, where they would, one would be positive, one would be negative, so I think the 12 has to be positive, that has to be negative. So we're going to cross that off, and we'll do it our grouping way. So I get 3x squared plus 12x minus 5x, and I know it's that way because if I add those together, I get to the positive 7x, and minus 20. Let's factor out on this one a 3 and an x, so I'm left with x plus 4. And on this one, make sure that sign comes down as negative, and we're going to change the signs as we factor out a 5, and that leaves me x plus 4. And then as we work through with this, so remember that's one of my answers still. I'm going to get x plus 4, and whatever I have left is the 3x minus 5. Set that equal to 0, so I get negative 4, and I also get set this one equal to 0, so add 5 divided by 3, so I get 5/3. So my answers are 5 over 3, negative 4, and do not forget that 0. And then this last one says find the zeros of the function. Actually, there's 2 more left. Alright, so let's go ahead and factor this. So this is going to factor to x minus 8 and x minus 3. If I multiply negative 8, negative 3, I get positive 24. If I add those together, I get negative 11. So we are getting x equals 8, and we are getting x equals 3. But we want to make it a 0. Okay, so because there's a y value, my y value in this case is actually 0. So these are my 2 crossings of the x-axis if I had graphed this parabola. I'll definitely be working more with that. And last example. So it doesn't look like I can factor out a 3. So I'm going to do it this way. I'm going to multiply those together. So I get 36 times 3. So I get 108. I want the factors of 108 that add up to 31. So I get 1 and 108. 2 and 54. 108 divided by 3. 3 and 36, getting closer. 108 divided by 4 is 27, so 4 and 27. Looks like that'll work. If they're both positive, if I add 4 and 27 together, I get to the 31. So I'm going to go 3x squared plus 4x plus 27x. I could have flipped them. Plus 36. Again, remember, look at your first 2 numbers. So it looks like I have an x in common, so I get 3x plus 4 here. And then on this one, I can factor out a 9, make sure that sign comes down. So I get x plus 9 and 3x plus 4. So that's going to give me x equals negative 9. So that gives me 9 comma 0. And this one, if I subtract 4 and divide by 3, I'm going to get negative 4/3. So my other 0 is going to be negative 4/3, comma 0. Okay, that concludes this. So homework will be worksheet 5G. And what do we say we do every other even? So realize that it's actually two pages, a front, back, and a front. Have a great weekend, everyone. Take care of one another.